to the webinar, EFOY Fuel Cell Technology Accelerating Digital Transformation, sponsored by CIM Magazine and SFC Energy. I am your organizer, Michelle Beacom, Managing Editor of CIM Magazine, and my co-organizer is Ryan Bergen, Editor-in-Chief of CIM Magazine. Just a little housekeeping before we get started. To ensure you have optimal audio, please make sure you've clicked the computer audio if you joined by computer, and if you joined by phone, click the phone. If you have any questions during the webinar, please type them into your GoToWebinar control panel question box, and the questions will be held until the Q&A period after the presentation. And now I will turn the webinar over to Ryan to introduce today's presenter. Thank you.
All right, thank you very much, Michelle, and thank you everyone for joining us here today. Today's presenter is Chelsea Kovacs. She's the business development manager at SFC Energy. I just wanted to add one extra housekeeping note to Michelle's. When you do add questions, if you do add a question to the question box, I just encourage you to give it a proofread before you send it off, so that we can be sure that what I ask is as clear as you'd hope. All right, and without further ado, I give the floor over to Chelsea.
Morning, everybody. Just bear with me. I'm going to open up my slide deck. Okay, hopefully you can see my screen. So thank you so much. I appreciate everyone taking the time out of their day to join me. Digital technologies are transforming the operational landscape for the mining industry around the world by enabling efficiencies related to automation, collection of big data, and IoT, which results in productivity gains. Specifically in remote applications, these technologies often require a highly reliable solution that has a low greenhouse gas footprint and is in alignment with an organization's corporate ESG goals. So during this presentation, we'll talk about who we are as an organization at SFC Energy, and I'll walk you through a couple examples of some fuel cell technologies that are currently deployed around the world and how the mining industry uses them. So we are SFC Energy. We are a global organization. Our headquarters is actually out of Germany, and I'm sitting in Calgary, Alberta. I am the Canadian office. So if you're curious to learn a little bit more about us, we've got about 300 employees globally. In Canada, Calgary is where we're going to have the production facility. A lot of our sales team is going to be sitting out of this facility. We also have an office in Edmonton, Grand Prairie, Montreal, Vancouver, and we just officially opened up a new office in Toronto as well. Overall, we've got about 55,000 fuel cells installed around the world, which we're very proud of. One of the things that are really unique about SFC Energy is that we are one of the only profitable fuel cell companies in the world. We also have a number of different branch locations across the world again, but currently out of Calgary, we are servicing North America. So altogether, we're about 88 million in Canadian sales right now, with about 110 million operating hours on our fuel cells. And that's a really important number that we're very proud of, which means we're producing 7.9 million kilowatt hours of clean energy. So I'll get right into the technology. Just kind of backing it up and highlighting why you would use a remote power solution in the mining industry. I mean, as we all know, mine sites are not located in cities. They're typically challenged with harsh environmental conditions, extreme weather. It's going to be really cold. I don't know if you can tell, but in my background, it's freezing cold in Calgary right now. And the other thing with mines as well is that they're very large. So you're not typically tied to grid infrastructure. So looking for a remote power solution that can service harsh temperatures and cover over a large mine site is going to be very critical. There's two different types of fuel cell technologies that we offer that produce power. First one is going to be direct methanol, and the second one is going to be hydrogen. For the most of this presentation, I'm going to spend the time talking about the direct methanol fuel cell. This one's highly commercialized and going to have the largest installation footprint in North America and around the world. Hydrogen is a technology that's readily available in the European market, and we're working to bring it into North America right now. But I will highlight some of the applications that this fuel cell will be suited to as well. So in looking at methanol fuel cell technologies, this is low power systems. So we're not talking about AC power, we're talking about DC power. On this side, I'm hoping you can see my mouse, but these units that you see in the white casing here, these are designed for the consumer industry. So these are going to be ultra low power, starting at 40 watts, and these are going to be more designed to go in a boat or an RV or a yacht. In the middle here, in the gray casing, these are the Pro series. So these are going to be designed specifically for industrial applications, and this is where we have the largest installation around mines around the world. So there's a couple different versions that we have, but they start as little as 40 watts, 125 watts, and then depending on what your application is and your load, you can parallel multiple units together to get to rated power. But during this webinar, I'll cover over how we size and design those systems because we'll take care of that for you. Then next, we've got our Pro 12,000 system here. This is again a direct methanol fuel cell, slightly different form factor. This one was specifically designed for the telecom industry. So it sits in a 19-inch rack, and this one is producing 500 watts continuous. And you can parallel multiple 500 watt units together to reach a maximum 2.5 kilowatts. Once you hit that 2.5 kilowatt territory, that's where we'd actually start talking about the hydrogen fuel cell, because that fuel cell, each module is going to produce 2.5 kilowatts. And again, we can scale up to 50 kilowatts when it comes to hydrogen. So essentially, we've got a fuel cell for every power requirement when we're talking about low power. So just going into how the direct methanol fuel cell works, easiest way for me to explain it is think about it as a smart battery charger. Let's just say you've got a remote mine site, and let's say it's a telecom system or a repeater site. So it's not going to be drawing a lot of power, but you're going to have a PV array and you're going to have a battery bank. Your load will be pulling off of the batteries, and as your load pulls off your batteries start to discharge. When you integrate a methanol fuel cell into this type of package, what it's doing is it's monitoring the state of charging your battery bank at all times. So it's looking at your battery voltage, and it's going to start cycling on and off based on the set points. So really what we're doing here is we're preventing your batteries from deep discharge, and we're going to keep them at an optimum charge cycle so that you're going to get as much life out of your battery bank as possible. So again, the simplest way to explain it is it's a smart automatic battery charger that's not producing harmful emissions. Typically, the way that we're designing these systems is to work as supplemental power to solar. We're in an age right now where everyone's looking for renewable energies and they want to reduce their carbon footprint as much as possible, especially for clients that are going to be sitting in Canada. Solar is great for a lot of the year, but then when we get into the winter months where there's low sunlight hours, that's where solar has its challenges. So the way that we design our Pro Energy solution is to work in conjunction with solar. So again, when we're sizing these systems, what I'm going to do is I'm going to look at your load profile, and I want to understand what's your average continuous load. That means what devices are running continuously, what devices might you have that are going to be running infrequently, and what's their peak power demand, and how frequently are they peaking. So then from there, what we're able to do is map out your average power requirements. Then from there, we're going to look at the location that you're looking to install this system, and we're going to model solar as well. So we're going to try to size solar to work during the summer months when solar availability should be there. And the fuel cell is going to do the bulk of the operation during the winter when solar just can't keep up with the load. That being said, when you have a fuel cell integrated into a solar setup, you've got the reliability there regardless of what solar's doing. So for example, I had a mining client who was monitoring their fuel cell performance, and they noticed that in the summer months, their fuel cell was running, and they didn't really understand what was happening, so they sent someone out to see the site. At that time, someone had stopped by and swiped all of the solar panels, so the EFOY was carrying the burden of the full site load. So with that, that just means there was no downtime. The fuel cell was able to keep the site operational. The trade-off was just a little bit of unexpected fuel consumption. So really, the nice thing about having a fuel cell for reliability, adding to these sites are highly critical typically. So having the reliability there with the fuel cell integrated into your solar system is going to basically make sure that we're not sacrificing any operational inefficiencies by using a renewable energy source, and you're going to get very long autonomy. And I'm going to cover over that in the next slide. So one of the unique things about a methanol fuel cell is obviously our source of power is going to be methanol. Methanol is very high energy density. And so when you look at the energy density here in this graph, this just kind of gives you an idea of how much power is available in a fuel cartridge. And then if you want to compare that to typically when you're doing like an off-grid system and it's solar, you're putting your autonomy in your battery bank. So there's a significant footprint difference when you're looking at a hybrid system. So for example, if you had a 50-watt continuous load and you were using 2 M28 fuel cartridges, that's going to result in 51 days of autonomy in this fuel alone. So that's not factoring in what solar is able to contribute. This is honestly just looking at the fuel. So again, keep in mind, the fuel cell is only going to start and stop based on battery voltage. So when we're sizing these systems, I'll ask you, what is your desired autonomy to achieve at site? How frequently do you want to go out and replace the fuel cartridges? A lot of our oil and gas clients only want to visit site once a year, typically after the winter. So we'll size a system for once a year replacing the fuel. The way that the fuel cell is going to work as well. So it's going to have 2 or more cartridges in the setup. We can scale with a fuel manager. We can add as many fuel cartridges as we want to achieve your desired autonomy. But the fuel cell is going to drain cartridge 1 completely empty. It's going to automatically switch over to cartridge 2, and it's going to continue that for as many cartridges as designed in the system. The fuel cell has Modbus TCP communications built directly into the firmware, and we also offer a cloud service. So you'll know when the fuel cell is running at all times, you'll get error codes, and you'll know your fuel status at all. So you should never get a call out at 5 in the morning saying, hey, our site went down because the fuel cell ran out of methanol and can't produce power. That would be maybe someone ignoring low fuel alarms. So really, it's just the autonomy and energy densities that's really unique about methanol fuel. The other nice thing about these methanol fuel cartridges is that they're engineered to be spill-proof and tamper-proof, and they carry UN certification. So you can fly these on a helicopter, you can put them on the back of an ATV. When you're swapping out the cartridges, it takes less than 10 minutes. There's no way that you can get methanol on your hands. You dispose of an empty cartridge, you put a new cartridge in, and then you're simply going to press reset on the fuel cell. So it's very simple to handle, very easy to operate. And the thing that a lot of our operators like about the methanol fuel is that you're not paying a commercial truck to come out and refuel these systems. You can purchase your fuel cartridges and swap them out, and an operator can do that all on their own. One thing that's also unique that we do is we run a program called SFC Academy, where we're providing free training for anyone that's purchasing these systems, just to make sure that you're fully comfortable with these systems. We want to make sure that you know how to troubleshoot them, operate them, and that there's no need to necessarily rely on us for any service and maintenance, although we always offer support as well. We do have a 24/7 customer support line that we don't charge for. Then we get into hydrogen. So just backing it up, between the 2 different technologies, the real difference is going to be the electrolyte and the operating temperature and the stack. So on a methanol fuel cell, you've got a platinum catalyst, and obviously the source of power, the fuel source there is going to be methanol. When we're talking about a hydrogen fuel cell, hydrogen is going to be the source of power here. So there's a couple different ways that you can use a hydrogen fuel cell. Again, each module is going to produce 2.5 kilowatts. It's going to come with a master control unit, and we can put multiple fuel cell controllers into one system to meet rated power, whether that's 5 kilowatts, 7.5, 10, you name it. So there's a couple different ways that you're going to look at this technology. It's producing higher power and was really designed to service the telecom industry. So you're going to use it as primary power or backup. So if we look at, let's just say we've got a client that's got a really critical grid supplied telecom tower, instead of using a diesel generator, they want to explore a fuel cell option. So what the fuel cell is going to do, very similar to the methanol fuel cells, it's just going to wait for that UPS, and it's only going to turn on in the event of an emergency when grid goes down. So you're going to have a battery bank, fuel cell is going to turn on based on the battery bank. It takes less than a minute for it to be producing full power. Once your grid is back up and operational, then the fuel cell is going to sit dormant. So there's no degradation while the fuel cell is sitting in standby mode. It's quite simply just sitting there waiting for grid and the need for it to back up the grid. Then if you look at an off-grid power system where it's going to be considered more primary power, there's a couple different ways that you could do this. Usually we always try to pair with a renewable energy source as much as possible. So similar to the methanol fuel cell, you're going to have your solar array. A lot of our clients that are considering hydrogen right now also want to integrate with wind. And so in that situation, you're going to have your renewables tied to your battery bank. Again, the fuel cell's monitoring the battery bank, and it's cycling on and off based on your battery voltage. There's a lot of interesting technologies that are coming out right now, because I think the current hurdle we have in Canada when it comes to hydrogen fuel cells is more hydrogen availability. Our infrastructure is starting to get built out, which is nice to see. We're definitely not as far along as countries in Europe, but over the next couple of years, we're definitely going to start seeing hydrogen readily available. I mean, there's still the Linds and the Air Liquides of the world that have this in bulk cylinder packs, and we're starting to see a lot more different storage options for hydrogen. But on-site hydrogen generation is going to be really interesting. So we've got clients right now that are using electrolyzers to do that. An electrolyzer is essentially using water to create hydrogen power, and then as that hydrogen is available, they're using the fuel cell to capture and produce power. So with the hydrogen, you're either going to look at it for primary or backup. One of the other technologies that we're trialing right now in Europe, and we're really excited to bring to North America, is our emission-free generator. So this is using hydrogen fuel cells, obviously, and then you've got the hydrogen supply directly built into the cabinet as well. So this is going to be environmentally friendly. I don't think I mentioned it, but with the hydrogen fuel cell, there's 0 carbon emissions produced. So as we're looking to get away from diesel and reduce our emissions as much as possible, hydrogen is going to give you a very high delta in emission footprint, especially for those of you that are looking to generate carbon emissions, or sorry, carbon offsets. This just gives you an idea of how the hydrogen fuel cell system could compare to a diesel generator system. But what I want to talk about is this cabinet here. So this is an example of how we would design an outdoor enclosure. These modules are the fuel cell. You've got the master control unit here. We've got our set of startup batteries, and then we've got the hydrogen bottles here. So there's a lot of different ways that you can look at hydrogen storage. I mean, these are bulk cylinder packs, but we're starting to see tube trucks come out now as well. And you can package a hydrogen fuel cell either in an indoor system in a rack. You can do an outdoor X-series enclosure, which is what we're bringing to the market. Or you can also look at putting this inside a shelter or a sea can. But if you look at that comparison on what you're going to reduce in carbon and how much fuel you're going to save, it's pretty astonishing. This is just another comparison on diesel generators. Really, I mean, the emission footprint, like I've talked about a couple times already, is a big thing. Same with the maintenance and repair. As you know, with a diesel generator, you've got moving parts, so you've got to go and do frequent oil changes, and you're replacing fuel quite frequently depending on the use. When you're looking at a hydrogen fuel cell, it's very low maintenance, and again, there's no aging when it's in standby. The other differentiator is the noise. We all have heard a generator at a campsite in the middle of the night and rolled our eyes, but with the hydrogen fuel cell, it's just a silent hum, so it's nice and quiet. And then on the methanol fuel cell side, you probably wouldn't even know that the methanol fuel cell is running because it is very silent. Some examples right now of how we're using this technology. Again, for the most part, this is going to be methanol fuel cells, but you could use it for security and surveillance and access control, environmental monitoring on a tailings pond, communications, rail signaling, and we have some clients as well that operate their own private rail networks. So they're using that for signaling and then also communications on those rail sites as well. So this picture that you see here, this is a trailer solution that's a turnkey system that we offer. This is for an open pit mine. Essentially what that client is doing is they need the ability to move, whenever their haul trucks are moving into an area that operations can't see or falls off their map, they'll go and move that fuel cell system to give them visibility, both from the camera and then from the data that they're collecting and sending back and forth as well. So this would be a 110 watt system. It's got solar panels here, and then it's got a retractable mast. So when we're getting into telecom sites, it's really interesting because we're always looking, do you need a mobile solution? Do you need a stationary solution? And what's your power demand? So we always try to use DC equipment whenever we can. We really want to try to minimize any inefficiencies, because when you switch over to a remote power system, if we're powering AC equipment, it's absolutely doable, but there are some losses that we need to take into consideration. So DC is just a much more efficient way of doing it, but I can understand not always possible. So again, if you have a telecom site, you want to consider what the fuel cell could look like, depending on the equipment that's there. We might want to look at doing an outdoor enclosure where we can package, let's say it's a small radio and an RTU in the side cabinet of the fuel cell offering, because what the fuel cell is going to do when it produces power is it's also going to produce heat. So we capture that heat inside our cabinets, keep our batteries nice and warm, and then try to keep some heat on some of the other electrical equipment that we're powering. You can also put a fuel cell system, let's say you have an existing shelter, because the fuel cell is not producing any harmful emissions, you can easily integrate it into a shelter and have it operating, and benefit from that waste heat it's producing as well. Then security and surveillance. This is going to be probably the most common application you'll see fuel cell technology being used. Generally, these cameras require very minimal amount of power. On average, I would say a system could be anywhere from 45 to 75 watts. So we're able to provide stationary cabinets like you see over, I've lost my mouse, stationary cabinets over here, or we've got mobile solutions as well. And really, the value and the benefit that we're bringing to this market segment is the silence and then the uptime. I mean, security and surveillance is a critical application. If you're using a solar system, there is the potential for downtime, but having the fuel cell there to back up your solar system means that you're going to get 100% uptime. Then there's environmental monitoring. So this is a system where we have a client that's monitoring the movement on the mine site walls. So what they chose to do is they have these little geo huts all around the perimeter of the open pit mine. We took one of our outdoor enclosures, stuck it inside that cabinet, and we're providing power to the laser here. So you can see that this is a really cold and harsh environment. So this entire package is rated to -40 degrees Celsius. It made sense for them to just take that enclosure and put it inside the building because they didn't want to fully insulate this building. But this kind of speaks to the fuel cell's performance in extremely cold conditions. Then we've got rail and traffic systems. So this example here is going to be in Europe, and this is going to be the hydrogen fuel cell. So they've got a number of systems installed. I believe this was a project that they actually did in conjunction with the government, and it's powering autonomous rail control and communication systems. So I am going through this presentation a lot quicker than I expected, but this kind of gives you an idea of what we offer at SFC Energy. I mean, we are working towards a climate neutral world, and it's really exciting to see that there are actually commercialized and proven technologies that can support this transition. So I encourage everybody to reach out to me and talk to me about your application. If you're interested in this technology, again, we can integrate into an existing solar site that you have that might be a little bit problematic. You might be spending some money replacing batteries quite frequently, or you might be experiencing downtime, or we could just be displacing an emission producing device as well. So thank you, and I'm hoping we get some questions. But this is my contact info. Don't hesitate to reach out to me by email or cell phone.
All right. Well, thank you very much, Chelsea. Yeah, we do have some questions, and let's get into those. So Joe Milborn would like to know what type of fire suppression system is required for the methanol fuel system.
That's a good question. None is required. There's no combustion process when we're producing power. Everything is done through chemical reaction. So you actually don't need to do that at all.
Okay. And also from Joe, this is a numbers question. Put you to the test here. What is the carbon emission for the what are the carbon emissions for the methanol fuel cell per kilowatt produced?
That's a good question, and I would ask you to send me an email. So it's a small amount of CO2 that's produced when we're operating. I don't know the number off the top of my head, but I do know that we've got a lot of clients that are, because it is so emission friendly, they're able to generate carbon offset credits by installing this technology. So it's similar to a human breathing when we are producing power. The thing to keep in mind is we're generally sizing these systems in a hybrid configuration. So you only want to factor in the carbon emissions that it's producing when the fuel cell is operating. So what I would do is if you're pulling this system into your SCADA network, I would look at how many liters of fuel you've consumed, and then we can apply that mathematical equation to the liters of fuel consumed to figure out the CO2 footprint.
All right, great. So you'd mentioned in the preamble that you're in Calgary and it's minus 25 there. So the next question is on the topic of temperature. Stefan Lopat asks, what is the efficiency loss with lower temperatures?
There's no efficiency loss with lower temperatures because the fuel cell is maintaining its internal stack temperature at all times. So what that means is that if the fuel cell is installed, let's say in an open enclosure, and it starts to get a little bit cold, it's going to run antifreeze mode and it's going to maintain its internal stack temperature. So it's not like a thermoelectric generator that's going to kind of produce more power or less power depending on what its temperature is. The fuel cell maintains its own core temperature.
Okay. Now, do you have a recycling program or recycling partners for the empty methanol cartridges?
Yep, so most recycling depots will take the methanol fuel cartridges. If for some reason in your area they're not comfortable because they've never taken that cartridge before, we will dispose of them for you.
Now, I will concede, I'm not sure if you've answered this question, but the temperature rating of the EFOY unit.
Yeah, that's a good question. So on the methanol fuel cell, it's rated to, I believe, minus 20 degrees Celsius. So that's why I would never just sell you the loose fuel cell. We would want to look and see how we want to package it. So all of our energy solutions are rated to minus 40 degrees Celsius, and then they're tested down to minus 60 degrees. So we have, just to give you an idea of the performance in cold weather, we did a project with the Mosaic Expedition where they're monitoring the climate change on the glaciers. So we actually have an EFOY system that's running in the Arctic. And so just kind of speaking to the performance, but it is inside a Pelican case, and that entire Pelican case is rated to minus 40 Celsius.
Okay. So Juan Romero asks if there is any regulation in Canada regarding special safety protocols and procedures to handle the hydrogen tanks.
I don't know the answer to that. We're in the early stages of bringing this to market, but I would assume that there will be some regulations around handling hydrogen storage, but that's really where, if you were looking at installing a hydrogen system with us, we would be working in conjunction with a partner that would provide the hydrogen supply unless you were producing it on site, and they would help walk you through what considerations you need to make to bring that hydrogen supply to your site.
Okay. So Scott Curry, you can take another run at this if I don't get it right, but he'd like to understand the relative cost of the platform as compared to diesel.
Okay, well, because we're bringing to market hydrogen, I will give you pricing, an example of pricing on a methanol fuel cell, which is not really, I mean, it's going to vary depending on what your actual load is in the system. But let's just say for pricing's sake, you had an outdoor cabinet, it was a 125 watt solution, and we provided you with full turnkey setup. So that's going to include batteries, your enclosure, your fuel cell, a year's supply of fuel. You're probably looking at about 22,000 Canadian, and then your operational expense on a 125 watt system could be around $500 a year in fuel costs.
Okay, and more about costs from Dale DeClerc, the approximate cost of an MT60 fuel cartridge?
I believe it's around $500 Canadian.
Okay, and is there a freezing point for hydrogen?
I don't know about honestly, I don't know about hydrogen, but on the methanol side, methanol won't freeze until -97 Celsius. So we really don't have to worry about the freeze point when we're looking at an off-grid methanol system.
Okay. So is this primarily an outdoor installation? Are there underground applications or enclosed spaces where this might be deployed?
Yeah, I would say for the most part, we're doing them in outdoor installations, like we're providing a full cabinet that's outside. That being said, we've got lots of methanol fuel cells installed inside existing shelters. You're only really going to see this technology though at a remote site. So I could have someone that has a shelter that's existing, that's got all of their telecommunication equipment built into it. And then I can just easily go in and put the fuel cell right inside that enclosure. Because again, it's producing power through a chemical reaction with no harmful emissions, and there's no combustion process at all.
Okay. So Armand and Mary would like to know what the lifespan of an EFOY unit might be.
That's a good question. So for the new Pro series, let's just use again 125 watt as a benchmark. At 6,500 runtime hours, it's going to be producing around 85 watts of power. So power degradation on a fuel cell is going to be linear. What's going to depend on what you consider end of life is what is your site, what's the equipment power demand, because there's still going to be a delta there. So at 6,500 runtime hours, that fuel cell is producing 85 watts. But if your load is 60 watts, then you still have a lot of usable life. Keep in mind, we're designing this to work in conjunction with solar. So the fuel cell is not running 100% of the time. When we're sizing these systems, we aim for it to run between 500 and 1,000 runtime hours a year to give you the maximum life expectancy as you can. And when you ask for a proposal, we'll model that as well. We'll give you a chart that says this is what we estimate your fuel consumption to look like in liters in a year, what your cost is going to be, and these are your annual projected runtime hours a year as well. And then when a fuel cell comes to end of life, you can refurbish the stack and rebuild it so that it's producing full power again.
Okay, great. So when would the medium size and larger stationary power units over 20 kilowatts be available in Canada?
So we should be ready to start doing proposals, giving you firm pricing by the end of Q1 in 2023, and then you would be taking delivery probably Q4 of 2023. So in Calgary right now, we've got our demo in-house. We actually have our hydrogen team from Germany in this week that's providing us with training. So if you're Calgary based, we can start bringing people in and showing you the technology, and we can start kind of pricing it out and talking about what type of system might make sense for your application, but you would be looking to actually get your hands on it later next year.
Okay. So for the hydrogen units, presumably water is produced in the process, and I guess how is that managed?
Yep, good question. So, and I didn't cover that on either fuel cell, so I'm glad someone asked that question. So yes, water is a byproduct of the chemical reaction on both fuel cells. On the hydrogen fuel cell, it's going to be water vapor. So the way that the cabinets are all designed is we're going to route the water vapor outside of the enclosure. If it's an indoor solution and you want to have it installed inside, then we would look at making sure that we've got a way to vent that water vapor out. When we're doing the methanol fuel cell, there's an exhaust line that comes right from the fuel cell. When we're doing a cabinet, for example, we'll fully heat trace that exhaust line and we'll route it outside of the cabinet so that the water driplets just collect on the ground. It's a very small amount of water and it's just water. It's environmentally safe, but it is fully heat traced so that we're preventing any freeze up from happening. But again, the water that's coming out of the fuel cell is extremely hot. So freezing isn't generally an issue when it comes to water exhaust.
Okay. Well, it seems we have exhausted the questions. Unless anyone has anything further they'd like to ask Chelsea. So yeah, contact details. If there are further questions, you can always reach out to Chelsea at the number on the slide. Thank you very much.
Thank you, everyone.
Thanks, Ryan. Thanks, Chelsea. I'd like to thank all of our attendees and ask that you please fill out the short survey that pops up on your screen at the close of the webinar. A link to the video recording of this webinar will be emailed to you tomorrow, and we hope to see you at our next CIM Magazine Solutions Exchange webinar. You can find a listing of the latest CIM virtual events on our calendar of events at cim.org. Thank you very much and have a good day.